Okay, so we're gonna go over Boggle first. So I don't know how many people finished it, probably a few anyway, right? So that's fine. So there's there's different phases, different levels of implementation that you could go through. Whatever you got is fine. If you didn't get to Boggle, that's also fine. So you're not expected to do all of every challenge. That's just not realistic. Okay, so the Boggle solution, first thing we'll do is I'll just go through the process. Let me share my screen of cloning the repo. Okay, so I'm gonna fork the repo first. Can you guys see my screen with the GitHub on it? Okay, all right, so first thing I'm gonna do, this is November Platoon's Boggle challenge. I wanna make it my challenge. So I'm gonna fork it over, go to fork here. Okay, I'm gonna fork it to my account here. All right, now that it's forked, I can see that it's mine. So Chad Mowbray /Boggle. Now I'm gonna clone it down. So I'm gonna clone my repo. So I'll copy this, and I already have this prepared here. So I have the folder that I wanna work out of, and I do git clone, and paste in that URL. Now if I go in here, I should see everything. So I have the Boggle board set up, and I have the README. All right, so that's how you get started. And we can look at the README here. So Boggle, if anyone has ever played this, I realize that as I get older, things like Boggle, I can't just assume that everyone knows what they are. So Boggle is just a board game, family kind of board game, and you get a box. It's got a grid on it. It's got a bunch of die with letters on them. You shake it up, and then the die settle down, and you just get like a grid of letters, and then you try to make words from that. So we're gonna try to model this with code, and we'll start with a very general model, and then make it correspond closer and closer to reality. Okay, so step one, the basic Boggle board. So this first iteration of a board will not care if it's possible, blah. So in the real game, there's dice, there's a limited number of combinations of letters you can have. Here, we're not concerned about that. So if we just look at the basic, the core implementation, we see that there's a Boggle board class, and then there's a core instance method shake. And if we look at the repo here, we see we have the class Boggle board with an init and a shake method. So that's good. It's throwing an error, so I'll just go ahead and add a pass. This is an easy thing you can do when you're just, you want to have a mock-up, but you want it to work. So this works now. So I can actually create an instance of this Boggle board class. So C equals Boggle board, something like this. Okay, and I can see that I get this Boggle board object. So it's a real thing. This is a real live working class. It doesn't do anything, but it exists now. So that's a good start. So we now have a class that has the basic method that we want. So now we need to work on actually implementing this method. Okay, so shake is the method. It's going to modify the board by filling each cell with a random uppercase letter, A through Z. Okay, our code should output something like this. Okay, so we'll start out with a general model, and rather than spend a lot of time typing that up, oops, I'm just gonna copy this. Okay, so in the init method, so when we have a class, we need to figure out where we're going to put stuff and how we're going to organize it. So we need to have a model of the board, right? And that model of the board can change. So we're going to run the shake method, and it's going to create basically a new random distribution of letters. And we can run that method multiple times, and it's going to come up with a new board every time. So the question is, what needs the board? There are a few different answers to that, but I'm just going to, for now, assign this to an instance. So self.board model equals, and I've chosen to go within an array of arrays. This is not the only data structure that you could use, but I just, you could make arguments that there are others that would be better, but this is what I went with. So this is now a representation of the board. So I can actually print this out now. So I can print out c.board model. Okay, so that prints out. It's not very helpful. So there's actually some built-in. Python has a lot of built-in things in the standard library, but you have to import them. So you don't just get them for free entirely, but you have to import them, but they're available. You don't have to download anything. So there's something called pretty print. So I'm going to import that from Python. So import. And then instead of printing, I'll just do might have to do dot. So there's a module called pprint, and then there's a function also called pprint in that. Okay, so this just makes it a little, especially when you're dealing with like things like JSON objects, which we'll deal with later, or objects and arrays. Using pretty print is just a handy thing. So we use pretty print for now, so you can see what this looks like. So it's a nice 4x4 grid. All right. So we have our basic layout here. So it looks like we've fulfilled this requirement. So when a new Boggle board is initialized, the output should look like this. So we've initialized our Boggle board, and we've put it in our init. So now we have something that looks like a board. Okay, when shake is invoked on our board, it should output something like this. So we need to implement shake in such a way that it uses this board model, but transforms it. So fills in for every, we don't just want asterisks, we want random letters. So there are a number of ways that we could try doing that. So for one, we need capital letters, right? So if we need capital letters, this is a limited set of data, we could just write out something like capitals and then have an array, or just maybe even just a string and do A, B, C, and so on. And that's fine, and that would work. We can also, again, rely on Python's built-in library. So most things that we do are going to be are problems that other programmers have encountered and have solved in a way that is probably better than what you're going to come up with on your own. So Python has a number of different modules. So I'll just mention this. This is kind of a cool thing to explore. Python module of the week. So this guy kind of goes through a lot of the built-in modules and has a write-up with some examples on all of them. So if you're interested, it's a very rich library. The Python standard library is very rich. There's all kinds of stuff here, and as you can see, there's a lot here, and this is not all of it. But there's a string module. So let me just do. Okay, so there's this built-in string module. So now I'm at the Python documentation. So string module, and I can see that there's kind of built-in constants, right? So this string module just has a bunch of constants that we can use. There's string.ASCII letters. This is all the ASCII letters, including uppercase. There's also just this ASCII uppercase. So it's just this. So, it's something fancy. We could just write this ourselves, but if this is available, you might as well use it. So we'll go ahead and do that. So we're going to import string. So there's two ways to handle an import like this. We could just import the whole module. So im string, and then when we want to use it, .ASCII. So I'm getting the IntelliSense here. We could do string.ASCII uppercase, right? So we're importing the module, and then we're saying this module, and then the specific thing we're looking for. We could also be more specific in our imports. So you could say from string, so from the string module, I want to import not everything, I just want one thing from there. So ASCII uppercase. And then here, I don't have to refer to the module anymore. I can just use it as though I had, written it in my code myself. So I've imported this specific feature. Now I can use it directly. Okay. So now I've got all these letters. What are we going to do with them? So what we need to do is iterate over, and since I'm using an array, I'm going to have to access every single element. So you could use a double for loop or something like that. That would work fine. We can also, we can also use a more Pythonic approach. So since we're coding in Python, we can use some of the nice features that are specific to Python. So I can do BOARD equals, and we talked about what are they called? I'm blanking on the name for some reason, but anyway, so it creates an array. I don't know why I'm blanking on the name. Anyway, so it's kind of like map. So in JavaScript, you have map where you have an array, and then you pass in a function, and it operates on every single element of the array and returns a new array.
List
right?
comprehension.
Thank you very much. Thank you. I don't know. So list comprehension does the same thing, except it's a little bit more flexible. So we're going to try our hand at writing a list comprehension. So this is going to be a little bit trickier because it's not just one level, there's two levels. So you can actually handle this with a list comprehension. The syntax might look a little confusing, but we'll start with the basics. So let's just make sure that we can access every single row here. So you can do something like row for row in self.board model. And we'll just print it. Well, actually, you need to call the function, right? So c.shake. Okay, so we've got this. So this is our model, but we need to go down one more level. So row for row in self.board model. So what we want to do is add another level onto that. So the syntax is a little bit confusing. You kind of got to go backwards when you're doing list comprehensions. So we'll do let me rewrite this real quick. So item for row in item for row in row for C. This is always a little bit confusing. So do for position in row right. In row. So we'll do item for item in row for row in self dot board model. So this is, let's see, if we pick this, row is not defined, item for item. Yeah, so as you can see, this can be a little confusing. So item for item in row. Let's try if I do this. Okay. Right, so I have item for item in row. So each item in the row for each row in self.board model. So this comprehensions can handle this. We could do a double for loop, which would probably be easier, at least more intuitive initially, but this is a common kind of thing that you'll see with in Python code, and it can get confusing, as you've just seen, when you have embedded for loops with conditionals and other stuff like that. Okay, but we don't just want the item, we want a specific letter. So let's just try adding a dummy placeholder and see if we get a bunch of A's. Okay, so this looks pretty good, and I'll do pretty print here so I can see it formatted better. Okay, so we've taken our model, and we've used it to generate a board, and we're replacing every single element with an A. So that works. But we don't just want A here. We actually want to choose a random capital letter. So we can write anything here that will return a value. So we can also use random. So we could do something like ASCII, or we'll use caps at 9. So I'm just going to choose the 9th thing in the array, so that happens to be J, right? But we want this to be random. So Python also has another built-in library called random, and there are a whole bunch of tools in random that you can use. We're going to use something called choice. So it makes a random choice from an array. So from random import choice. And instead of specifying what we want, we can do choice caps. And so this now produces an array of random capital letters. So we look back at our README. Okay, this looks like when shake is invoked on our board, it should output something like this. Okay. So let's see what happens when we do shake. And if we run shake again, do we get a different combination of letters? It looks like we do. Okay. All right, so So one thing we do right now is pull out. So we're going to need to be printing this board over and over again. So we can do that here. We can also pull it out into its own class method. So the README doesn't say to do this necessarily, but we can go ahead and do it because it seems to me like that would be a useful feature to have. So let's add a print board method. I'll take self, and then what we want. So when this board is initialized, right? So all we're doing down here is we're creating an instance of this Boggle board. Let me add a pass. So we create an instance of this Boggle board, and when we initialize it, self.board model is this, right? So if we try to print our board, we could just have it print this, but this isn't going to change. So the way we've set this up, we'll talk about functional programming versus object orientation on Thursday, but this is a way, this approach using list comprehension to return a new array is one of the features of functional programming. So there's something called pure functions. So this is a pure function. It doesn't alter anything outside of it. So we're not altering self.board model from inside this function. We're taking input, and I mean, technically this should be passed as a parameter, but that's fine. So we're taking input, and then we will be returning a new array. So that's the basic idea. So what we can do now here is in Shake, we have our board, and we can add a new instance variable here. So we can add stuff just like objects. You can add new properties to them after they've been created. You can do the same thing with a class. So we'll do self dot actual board equals board. Okay, so now if we check c dot actual board, we'll try to print it. We get an attribute error. Boggle board has no object. Okay, but if I run Shake and then check it, now it exists. So there's some order here. So if I want to make this print board method flexible, right, I want it to be able to print whatever board exists. If I haven't actually generated a board yet, I want it to print the kind of default board model. And if it does exist, then I want it to print the one that I've currently generated. So a couple ways of handling this. So, you know, the way that I would solve this is using a ternary operator. So we can set the value of a variable depending on what we're doing. So I could do something like so current board equals self dot board model. I'll do self dot actual board if self dot actual board, else self dot board model. So can someone tell me what's happening here with current board?
Basically, it prints a board with characters, and if there is no board with characters, it just prints the original board model.
Yeah. So then here, I don't have to call two different functions. I can do preprint. I can pretty print the current board. So let's try printing the board. So c dot print board. Actual board if. Oh,
Actual board doesn't exist until shake is run.
yeah. So I should probably change this around to self dot board model. Self dot actual board. Else. Let's try that. Okay. Let's see. Apparently I didn't test this when I was, yeah.
Would you be able to set self.actual board to an empty array in the init method maybe?
We could, so I'm gonna try to salvage this real quick, and I'm gonna keep it the way it was, but I'm just gonna do some error handling. I'm gonna write a try catch block, try current board is self.board model. Let me just go back to where it was here. Self.board model. Okay, so self.actual board. Okay, so I'm gonna, so that's throwing an exception. It's called an attribute error. So I can check for that. So try, I'm gonna do this. Except. So that. Okay. So we haven't really talked about handling exceptions yet, but this is one use case. So I can also accept, I can also give it, you know, attribute error. So this would be more proper. So I give it the specific error. So if there's an attribute error, so it's going to try to run this. It's going to try to assign self.actual board to current board. That's going to throw an attribute error. So I'm going to catch, or I'm going to catch the exception. I'm going to handle the exception, and then if it throws an exception, I'm going to say, oh, never mind. I'm going to go ahead and just assign self.board model to current board, and then I can print the current board, whatever that happens to be. Okay, and then so let's test this. Let's run shake. And then we'll run c.print board. Okay, so it looks like that works. So now we have a print method that can handle basically any state of our board. Okay, so looks like step one is done. Step two is going to introduce some more complications. So right now what we're doing is we're just using any old random letter from the alphabet right here. But the real Boggle game, here are the actual die. So each one of these rows represents a die. And then obviously whatever side the die lands on. So you choose one, randomly choose one from each of these rows. So again, I'm gonna save myself some typing. I'm gonna grab this, which I've already made. So we've got, I'll just paste it down here for now. Got kind of a big thing. So again, I made it an array of arrays. This is not the only option. This is a pretty big thing. It's kind of bulky. So I could take this and I could assign it, I could assign it maybe as a class variable or maybe as an instance variable or something like that. But I'm just going to kind of keep it out of the way. So I'm going to create a new file called storage.py. I'm going to put this in here. And then I'm going to import it. So I can import modules. I can import Python modules that are kind of in Python standard library. I can download third-party modules and import those and use them. I can also import and use things that I've made myself. So from this, okay, so now I'm importing die. We can go ahead and test if I can use that. So okay, so now I have access to this, but it's maybe a little cleaner to work with. All right, so now I've got my die. The thing is, we're gonna have to somehow do something with shake. So what's happening here is no longer good enough. We've got new requirements. We're gonna need to fix that up. So there are a lot of ways of dealing with this problem. We have to somehow, instead of just willy-nilly grabbing any old letter we want, we have to systematically go one line at a time through this other data structure and grab one. So that's going to be tough to coordinate, right? If we had, especially since we're using a list comprehension. So we could do something else and just use a bunch of for loops and kind of coordinate them and make sure that things are lined up. So it's, when it's on the right iteration, it's grabbing the relevant letter from the die array. But we also know that this is going to run 4 times 4 times. So this is going to run 16 times, right? Because of our grid. And this has 16 rows. So we kind of, we have that information, so we can use it to our advantage. So I'm gonna write another function instead of calling choice calling choice here. I'm gonna write my own function that's gonna do some other stuff. So def, we'll call it die helper, and we'll include self. And again, we're going to talk about functional programming on Thursday, but I'm going to use something called a closure. This is a more advanced topic, but just to, just to get some exposure. So a closure is basically, I'm going to call a function and I'm going to return another function inside of that function. But that inner function is going to have access to other variables that exist in the outer function. So that sounds a little confusing. So I'm going to go ahead and just write. So I'm going to use the fact that I know that this is going to iterate 16 times to my advantage. So I'm just going to create a counter here. So counter equals, we'll start it off at -1. We'll see the y in a second. And then I'm just going to call this, for now, inner. Okay. And then this inner function is going to increment counter right? It's going to increment counter, and then it's going to go and grab a random value from the relevant row in storage. So it's going to start, it starts at -1. I'm going to do equals counter plus 1. And let's see what our linter tells me. It tells me that variable counter is unbound. So there's a problem here. This may not make a lot of sense to you, but some of you have tried solving previous solutions by using a global variable in Python. So if I have a global variable called counter and I want to modify counter inside of a function that I write, I can't just do that directly because Python thinks they're two different variables. What I have to do is tell Python explicitly, hey, I have counter in global and I also have counter in a function. You have to tell Python specifically the counter in function is also global. It refers to that other global variable. So you just indicate it by writing global. Something similar happens here, but instead of global, there's something called non-local, which basically does the same thing. So I'm just telling Python, hey, I'm going to use this variable inside here, but I'm actually referring to this. This is not a new variable that I'm making. It's actually just referring to this. Okay, so I'm going to increment this, and then what I'm going to do is I'm going to go to my storage here, and I'm going to grab the relevant row. So the first time through, counter is going to be 0. So I'm going to access the 0th row here, and then I'm going to randomly choose one of the letters. Okay, so my letter equals, so I can access this 0, and then I can use this choice here. So choice takes an array and it will, so I'm randomly choosing one thing from the first row. And then I'm going to return it. So I'm returning from the inner function, and then I also have to return in my helper function. So this is a little bit confusing, but what I'm doing is I'm creating a function. I have a local variable here called counter, and then I'm returning an inner function that modifies counter and also does some other stuff. So when I call die helper, I can keep calling the inner function and keep changing counter. But I don't have direct access to counter. So it's a way of creating private variables. So other languages have private and public access to methods and variables. Python, I mean, there are a couple things you can do, but basically Python doesn't have that distinction. But if you use a closure here, then effectively you will have done the same thing. I can only call this function, and this function will change counter, but I can't directly access counter. So if you want to protect a variable, that could be good. So we'll go ahead and call self dot. Okay, so before we actually do that, we're going to need to call this function first. So we're going to need to, there's something called partial application or currying. Again, we'll talk about this more with functional programming. I'm just kind of introducing this. So we can say something like get die, and we'll do self.die helper. Okay, so I'm calling this function, And so this is returning, again, I'm not returning the called function. I'm just returning the function itself. So now I can repeatedly call this function. Right, so I've made a function called die-helper, which is going to have a closure. So I'm returning a function, not a function call, but a function. That function, that inner function, changes something in its outer scope. So this is called a closure. And then I use that counter to access different rows for every function call. I randomly choose a letter in a given row and I return it. And then that ends up here. So this is gonna, for every time it goes through, it's gonna give me a random letter from the relevant row. So I can try checking this. Let's see. My letter is going to return one row. Okay, so if I shake it, let's try printing. So NAAE, and looks like I'm stuck here on the first one. So let's see.
You only select from the 0th index of die.
Oh, thank you. Counter. Okay, let's try that again. So let's just make sure that we're grabbing one letter from each row. So ALOB. So ALOB. We'll check the next for ETDT, ETDT, ETDT. Okay, so it looks like it's working. I'm going through and I'm grabbing one from each. Another thing we could do, just we're talking about classes, so some of this is more advanced, but that's fine. It's good to get exposed to it. So notice how we're passing self here, but we don't use self anywhere in our helper method, right? So we can actually, so we could keep it like this and it's fine, but if we wanted to be a little bit more precise and maybe communicate, especially to other coders, what this method is actually doing, we can get rid of self and then add something that's called a decorator. And we'll use the static method. So we can talk more about some of this stuff. Again, this is more of like a functional programming thing, but a decorator basically is just another function. So it's a function that takes in a function and does some stuff with it. Just like this. This is a function, it returns a function. We have in JavaScript like map higher order functions. They're functions that take functions. A decorator does the same thing. This is just the peculiar syntax that Python has, but static method is just a function somewhere in Python. So now we know, and any coder that comes after us knows that this is like a helper function. So this function isn't going to change directly any property of our instance or class. Okay, and we can get rid of this now. Actually, we'll go ahead and leave that, and I'll show you something in a second. Okay. So are there any questions so far about what's happening? So there's a lot of new stuff here. So we're using classes. There's also some talking about closures. So there's a lot of new things, and we don't expect all this stuff to make sense immediately. But are there any questions about Boggle so far? All right, so we'll keep going. I think this is part 2, step 2. I think we're good there. So there's this last step is basically a formatting issue. So dealing with the pesky QU. So we want something that looks like this, so it's not aligned. So let's just see what happens. Okay, so let me change this method a little bit. So in order to print it out actually as a string instead of an array. So for throw in, calling it current board. Let's see. Actually, not string. We'll use join. Okay. So now we just changed our print board method, which is fairly easy to do. So we have our row, we're iterating over it, and we have an array, and what we're doing is we're converting each row into a string separated by a space. So now we have a nice grid, but what happens if we have a QU instead of, so there are a number of places where we could check this. I'm just gonna do it here, where we're actually returning a letter. So we can check if the letter is a Q or not. So again, I'll use a ternary operator. There are other ways to do it. So I can check. So we'll return my letter if my letter is not Q. All right, so we're going to randomly get a letter just like you're doing before, but we're going to do a small check here. And if let's see. So it'll return the letter as long as the letter isn't Q. If it is Q, then it's going to return QU. So let's run that. Probably have to run it a few times. Oh, got one on the first hit. So this works. So now our code spits out QU instead of Q, which is good. So it's more like the actual Boggle game, but now the formatting is off. So there's a few things we could do. Again, I'll just show you what I came up with. So I'll use a format string. Again, doing everything in the die helper. It's, you could make a good argument that we should pull out this formatting stuff into its own method, but I'm just going to do it here. So I'm using Python f strings, and I'm going to say my letter dot space. So I'm just going to add a space to every letter except for Q, and we'll see if that works. We'll keep going until we got a Q. There we go. So now we have a QU, and the formatting is still the same. Okay. So we're doing a whole bunch of stuff. We see we got our linter isn't happy with us for a couple different reasons. So Akash gave a great lecture about linting and code standards and so on, but I just want to show you that you can run something on the command line. So you can run pylint on the command line, and it'll give you output, and it'll kind of tell you all the things that are wrong with your code, at least according to pylint. So I can do Python. So I have pylint installed, and you probably do if you're using VS Code. Although you can, if you don't, then we can fix that. But Python -m And this is gonna basically allow you to run a module on the command line. And we're gonna run pylint, and then we're gonna pass it the file that we want it to check,
We
which
can't
is,
see your command line.
oh, you can't? Can you see it now?
Yep.
Okay, that's weird. Okay, so we'll run pylint, python-m pylint, and then Boggle board. And it's going to give us a whole bunch of output. So you can look through that. So you can see the summary is that, oh, my code has negative 2.3 out of 10. That sounds very bad. So there's a whole bunch of problems here, and look at all that. So you can, pylint is just one linting tool. There are others, and you can also specify, you can pass it all kinds of flags and options, configuration. But by default, it doesn't like trailing white space. So I can see Boggle board looks like 9.7. So there's a trailing space here. You can see there's a trailing space. It doesn't like that. So if I get rid of that and save it and rerun it again, hopefully that will disappear. See, our rating went up. It's now -2. So good for me, instead of -2.33. And that first one is gone. So you can kind of go through and look at it. Some of the stuff is formatting and spacing. Some of it is, oh, there's bad indentation. So it wants me to use 4 spaces and so on. Trailing white space. So some of this stuff is, you know, arguably just formatting, but there's also more significant things like missing module docstring. So pylint wants me to create a docstring, which is, you know, good professional practice. We don't have to do that here, but missing function or method docstrings also wants me to write docstrings for methods. Unused variable, so that's definitely something you want to check. So you can see here, okay, unused variable, get rid of that. Missing function or method docstring, again, attribute actual board defined outside init. So it doesn't like the fact that I added a new value. Where is that? So I added a new attribute outside of the init. So one thing that I could do, again, in terms of communicating what my code is doing, especially to other people, I can do self.actualBoard equals none. I can do something like that. So anyone who looks at this quickly knows that here are all the properties that this is going to have. Unused, pretty print. So anyway, so you can go through all this stuff and kind of, it's just a nice way of doing a sanity check. It picks up things that you don't notice, forces you to be more detail oriented. Okay, so that's all I got for
Hey, Chad, question.
Boggle. Yeah.
Is there just a command you can have pylint automatically fix your spacing issues?
Yeah, you should be able to do, like in VS Code, I'm sure that there are things that do that. Something like pretty print. If other people use those tools, anyone that, like, maybe it formats it when you save or something.
Yeah, I don't know what it is right offhand, but yes, there is a on save. You can specify your linting